Methane bursts may have warmed early Mars enough for liquid water to form. Interactions between methane, carbon dioxide and hydrogen in the atmosphere of ancient Mars may have created warm periods that allowed the red planet to support liquid water on its surface, according to a new study that may help in our quest for life beyond the Earth. There is plenty of geographical evidence that rivers periodically flowed across the planet's surface. Yet in the time period when these waters are supposed to have run, 3 to 4 billion years ago, Mars should have been too cold to support liquid water. Researchers from the Harvard John A. Paulson School of Engineering and Applied Sciences, SEAS, in the U.S. suggest that early Mars may have been warmed intermittently by a powerful greenhouse effect. If we understand how early Mars operated, it could tell us something about the potential for finding life on other planets outside the solar system, said Robin Wordsworth, assistant professor at SEAS. 4 billion years ago, the Sun was about 30% fainter than today and significantly less solar radiation and heat reached the Martian surface. The scant radiation that did reach the planet was trapped by the atmosphere, resulting in warm, wet periods. For decades, researchers have struggled to model exactly how the planet was insulated. Carbon dioxide makes up 95% of today's Martian atmosphere and is the most well-known and abundant greenhouse gas on Earth. However, carbon dioxide alone does not account for Mars' early temperatures. There must have been something else in Mars' atmosphere that contributed to a greenhouse effect. The atmospheres of rocky planets lose lighter gases, such as hydrogen, to space over time. The oxidation that gives Mars its distinctive hue is a result of the loss of hydrogen. Researchers look to these long-lost gases, known as reducing gases, to provide a possible explanation for Mars' early climate. They looked at methane, which today is not abundant in the Martian atmosphere. However, billions of years ago, geological processes may have released more methane into the atmosphere. This methane would have been slowly converted to hydrogen and other gases, in a process similar to that occurring today on Saturn's moon, Titan. To understand how this early Martian atmosphere may have behaved, the team needed to understand the fundamental properties of these molecules. We looked at what happens when methane, hydrogen and carbon dioxide collide and how they interact with photons. We found that this combination results in very strong absorption of radiation, said Wordsworth. This is the first time scientists have been able to calculate its greenhouse effect accurately. It is also the first time that methane has been shown to be an effective greenhouse gas on early Mars. The study was published in Geophysical Research Letters.